Okay, let's start by talking about what probability, theoretical probability is. Theoretical probability is the same as simple probability, which is what we were doing last week. So that is, what is the probability of rolling a 1 on a die if we know there are 6 sides to the die and only one of them is a 1. So the probability, the theoretical probability of rolling a 1 is 1 chance out of 6. And the probability of rolling a 2, there's only 1 chance out of 6 that could happen. And then the same thing goes for a 3. The probability of rolling a 3 on a standard die, there's only 1 chance out of 6. And it continues. There's only 1 chance out of 6 to roll a 4. There's 1 chance out of 6 to roll a 5. And there's 1 chance out of 6 to roll a 6. And we learned last week that if we add up these probabilities, 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1, 2, 3, 4, 5, 1/6, we're going to get 6 over 6, which is equal to 1. And 1 is also equal to 100%. Now, what is 1/6 when we turn that into a percent? Well, if you divide 1 divided by 6, so 1 divided by 6, and we multiply it by 100, we should get a percent is 16.6, and it's repeating, and that would round to 16.7%. So the probability of the simple probability or theoretical probability of rolling a 1, a 2, a 3, a 4, a 5, or a 6 is 16.7%. All right, let's look at the results from one of your classmates. This is their individual results for how many times they rolled a 1. It was 3 times. A 2 was 5 times. A 3 was rolled 3 times. A 4 was rolled 4 times. A 5 was rolled 7 times. And a 6 was rolled 4 times. And when we add them up, it comes out to 26, which it should have been 30, but that's okay. Now, this is the type of information you're going to see in a lot of your homework and classwork problems, and this is how you deal with it. If they ask you what's the experimental probability of, say, rolling a 1, then we're going to use this data. There were 3 positive outcomes out of a total of 26. So the probability of rolling a 1 would be 3 out of 26. And then we could do this one. How many times were 5 rolled? So the probability, the experimental probability of rolling a 5 would be 7 outcomes out of 26. Now, what I did with our data as a group is I combined the data of all the rolls that we did for the day, and there were 1,462 rolls. And I summed up, or I added up, how many rolls were 1s, how many rolls were 2s, how many rolls were 3, how many rolls were 4, 5, and 6. So if you look at the numbers, we have 263, 235, 256, 247, 232, and 229. This is actually really good data. The number of 1s rolled was the highest, and the number of 6s rolled was the lowest, and the difference between those two is just 34 rolls. That's actually really good. We would expect almost an equal number of rolls to occur based on our theoretical probability. Now, let's look at our relative frequencies. So what I did for relative frequency is I took the number of rolls for each outcome, and I put it over the total number of outcomes, so 1,462. So this is now the relative frequency. But when I look at this, it doesn't make a lot of sense to me, and I can't really compare it to what I just calculated for theoretical. So in this case, I'm going to change them to percents. So what I did to change it to a percent is I took 263 divided by 1,462, and I multiplied it by 100% to get 17.99%. So now when we look at the percents, these are actually very interesting. They're actually very close to each other. Again, because we go back to the number of rolls, we're very close to each other as well. All right, now let's look at how they compare to the theoretical probability that we calculated before, which was 16.7. And if you notice, the difference between these two for each type of roll, for each outcome, is pretty darn close. So if we were calculating the percent error, which we learned how to do that just before we left school, our percent error would be our expected minus our the outcome divided by the theoretical. And it would be a pretty small percent error. All right, last thing I wanted to do was see what does this look like, our data look like in a pie chart. So I took our percentages for each of the types of rolls and I just created a bar chart to see, I wanted to see if our slices were almost equally divided. And if you look carefully, they're pretty darn close. You know, these three slices are pretty close, and these three slices are pretty close. This one's pretty big, and so is this one. But overall, they're pretty darn close, which means you guys did a really great job with this experiment. Let's see if we can do that same thing today with our card drawing experiment.